Hi students, welcome to Physics with ER. So today we are going to discuss regarding the concept basic properties of charges. So these basic properties of charges you have been taken, which we can be classified into three types. So one which we can take it as additivity of charge, quantization of charge, and conservation of charge. Here first. So next one, which the second one, basic one, you have been taken it as a quantization of charge. Regarding this quantization of charge, which we can denote it as in simple form as with this equation. So always we are going to use this equation Q is equals to plus or minus N E, where plus represents that for positive and minus represent for negative. So what they have been given this a quantization of charge. So experimentally, it has established that all free charges are integral multiple of a basic unit of charge, which is denoted by E. Here, so we are going to discuss in detail. So regarding that, here E value, which is equals to, which you can take it as 1.6 into 10 to the power of minus 19 coulombs. So this is a one which you can take it as basic unit of charge. So for positive, we can use it as a plus. For negative, we can use it as a minus. So based on that, which we can tell it as in simple form. So that's which is nothing but charge is quantized means Q equals to plus or minus NE, where N is any integer, either positive or negative. So because charges either can be positive or negative, so based on that, N is an integer number. The basic unit of charge is a charge that an electron or proton carries. So whenever, as if you have been taken an example, so for example here, which I can take it as, so if I have been taken like this, so in this one proton are there, for example 5 protons. So for example, which I have been taken it as 5 protons. So if I have been taken, this is a charge, in this it is having 5 protons, along with this it is having 5 electrons. Okay, so on one more body, so this body is denoted by A, and one more body, so which I have been taken it as example as 7 protons and 7 electrons, because not to get confused, I'm showing it as a proton as a positive, electron as a negative. So whenever it should have to move from one body to another body, that's which it can moves in terms of integral format. That means here total number of protons and neutrons, total number of protons and electrons you have been taken only in terms of integral format. So for that, which they have been used as the basic unit of charge that an electron or proton carries. So charge on electron, which you can take it as negative, and charge on electron on proton, we can take it as a positive. So because of that, whenever we are using an electron under that condition, we can denote it by minus E, and that as a proton, which you can denote it by plus E. So because of that, that equation which you can denote it as Q equals to plus or minus NE. So electric charge is always an integral multiple of E is termed as quantization of charge. So that only we are simple form which we are showing it as, which is nothing but, so Q equals to plus or minus NE, which we are using. So the quantization of charge was first suggested by experimental laws of electrolysis discovered by an English scientist experimentally. So his name is which we can take it as Faraday. Faraday is a scientist name. So in order to prove this, E value is equals to some constant. It was experimentally demonstrated by millikan's in 1912. So in order to represent this, the charge, so international system, basic systems which we are using in our day-to-day life, that is SI system. So this charge which they have been named, so this charge is called SI unit, we can call it as a coulomb, and this which has been denoted by the symbol capital C. So on based on honor of a scientist named Coulomb. So here a coulomb, as if they have been defined as a unit of unit in terms of electric current. Regarding this, so in lower classes you have been studied regarding the current. So if you have been remembered, I is equals to, so which is nothing but Q by T, where Q represents that the rate of flow of charge. So this, with this equation, they have been taken it as Q is equals to I into T, so which they have been written. So here I value which they have been taken it as, which is equals to 1 ampere, and time T they have been taken it as T equals to 1 second. Now you can see this. So In terms of this definition, 1 coulomb is a charge flowing here, flowing through a wire. It is 1 ampere. 1 ampere. So in this system, that the value of the basic unit of charge with that, so which they have been given it as, that's value. So what I have been written, that's value is nothing but, so charge of electron or charge of proton, which we can denote it as with respect to E, that is nothing but 1.602 into 10 to the power of minus 19. So this is a one which we are going to use throughout the class 11. So this is a universal constant. How we are telling G value, small g value is 9.8. How we are telling are some constants. So Planck's constants, Rydberg constants, some constants which we are using like that. A charge which we can denote it by as a constant value as 1.602 into 10 to the power of minus 19 coulombs. So if you have been taken, there are about 6 into 10 to the power of 18 electrons in a charge of 1 coulomb. For this, so which we can take it as here. So if you take a Q equals to 1 coulomb, then the number of charges. From the definition of charge is quantized, we can write it as Q equals to, which is nothing but NE. With this, the number of electrons which have been taken, N is equals to, which is nothing but, so Q by E, as if they have been given. So Q value is nothing but 1 coulomb. By substituting that which they have been taken it as, which you can get it as, so N is equals to 1 by 1.602 into 10 to the power of minus 19. So which you are going to get minus 19. So if you have been done this value which is equals to 6 into 10 to the power of 18, which we can get it. That means here the given value which they have been taken it as a Q equals to 1 coulomb. With this we can obtain it as N is equals to Q by C. By substituting these values we can get it. So in electrostatics, charge of this large magnitude, hence we use the smaller units. So in order to not to use always as a coulomb, so especially while calculating the numericals, we are using it as a 1 micro coulomb. So 1 micro coulomb which we are using. So this is 1 micro coulomb. So as if you have been learned that micro is nothing but 10 to the power of minus 3. Or in terms of a millicoulomb, that's millicoulomb is nothing but 10 to the power of minus 3. So this is very, very important while solving the numericals, which you should have to be used. So just now, as if I have been said that a charge is quantized. So for that, which they have been taken it as. So for example, so which I have been taken it as like this. So in this condition, N1 are the electrons. So N1 into E. So which I can be considered, this is negative. Whereas protons which have been taken it as, so N2 into E. So N2 into E. So N2 into E, which as if I am using N2 into E, because electron is negative and proton is positive. If from one body to another body, for example, these are the two bodies which have been taken, A and B. If electrons which should have to transfer from one body to another body by processing of different cases, under that condition the difference so which you have been taken, which we can call it as, so which is nothing but that which have been taken, which we can tell it as N2 into E plus N1 into minus E. That means the difference which you have been done, we are going to obtain it as integral format. That's why we have been said that a charge is quantized. So based on this which you have been said, so always it is an integral multiple of E and can be increased also in steps of E, which we can tell it. So whereas, it's very important point, whereas whenever we are considering regarding macroscopic, so these cases we have been considered as a micro. If you have been considered in case of a macroscopic level, the quantization of charge has no practical consequence and which we can be ignored.